introduction. Firstly, you guys must know what is electricity. Electricity is the interaction of electric charge. Electric charge are fundamental property of proton and electron, which is make up every atom. Other than that, positive and negative charge are two types of electric charge, where proton possess a positive charge and electron carry a negative charge. Next is what is magnetism? A force that can attract or repel certain materials such as iron, and it caused by the movement of electric charge in certain objects like magnets and electric currents. Other than that, magnets attract iron and have two poles, a positive pole and a negative pole, whereas the magnetic force is strongest. All magnets share these properties. Okay, so next I'm going to talk about electricity and magnetism applied in transportation. Firstly, electricity, magnetism and transportation are interconnected through various technologies. For example, electric motors that commonly used in transportation rely on the interaction between electricity and magnetism. Second, electric cars and trains showcases the integration of electricity in modern mobility, offering cleaner and more sustainable alternative. Lastly, magnetic levitation train exemplify the fusion of magnetic principle with transportation, showcasing how this fundamental concept shape the future and of efficient and high-speed travel.
Hi guys, now it's my turn to explain to you guys about examples of real-world implementation in electricity, magnetism in transportation. There are three examples that I chose for my turn. Okay, the first example is electric car. Electric car use wireless charger system which is involve magnetism in the transfer of energy between the charging pad and the vehicle. Inductive coupling using magnetic fields enable the transfer of electric energy without physical contact. Other than charging system, the electric car also have electric motor which is operate based on the principle of electromagnetism. Inside the motor, there are permanent magnets or electromagnets. The interaction between these magnets create a rotating magnetic field, which in turn generate mechanical motion to drive the vehicle. The next example is electric boat. As we all know, every electric boat have a propeller and their engine at the back of the boat, which is the propeller receive electrical energy from the engine to make the boat move. In that engine, there is electrical motor function, which is primary component responsible for converting electric energy into mechanical motion to propel the boat through the water. Inside the electrical motor, there are magnets, either permanent magnets or electromagnets, that create a magnetic field. The interaction between this magnetic field and the electric current flowing through the coils generates rotational force, driving the motor and subsequently the boat. This concept makes the boat move forward and backward. Okay, last but not least is aeroplane. Aeroplane have electric power generation. Every aircraft have electrical generators powered by the engine, which is produce electricity to run the aircraft system and avionics. In some modern aircraft, auxiliary power units or generators driven by the aircraft engines generate electrical power. There is magnetism concept in this case because the electrical generator use the principle of electromagnetic induction, where the magnetic field is used to induce the electric current in coils of wire. The rotation of the magnet within the coil generates alternating current AC, which is then converted to direct current DC for distribution. Other than generates the electricity themselves, aeroplane also have navigation and communication system, which is use the concept of electricity magnetism. So, in this navigation and communication system, the aircraft will use radar, GPS, and communication radios rely on electrical compound system and magnetic field. In navigation, they have a sensor that use magnetism concepts, which is magnetometers, and magnetic sensors are used for navigation, providing information about the aircraft heading and orientation.
What is electromagnetism? Electromagnetism begins with the idea of electric charge, which can have either a positive or a negative nature, which similar charge will repel one another, while opposite charges are attracted to each other. Electric charges generate electric fields in their surroundings, and an electric field is an area in space where a charged object encounters a force. So now I will explain of how electric current generates magnetic field based on Ampere's law and Faraday's law. First, what is Faraday's law? Based on Faraday's law of electromagnetism induction, electrical energy is generated through the mechanical process of passing a conductor through a magnetic field, which Faraday's law says changing magnetic field produces an electric field. If charges are free to move, the electric field will cause an EMF and a current. A current is also induced if the area of the loop changes, or if the area enclosing magnetic field changes. So it is the change in magnetic flux. And then what is Ampere's law? Ampere's law explains that the magnetic field generated by a constant electric current, as originally proposed by Andrew Marie Ampere. When an electric current passes through a conductor, such as a wire, it creates a magnetic field in its surroundings. This magnetic field takes the shape of a centric circle with the conductor at the center. The intensity of the magnetic field is directly linked to the amount of the current flowing through the conductor. What is the role of electricity in transportation? Role of electricity acts as the primary source of energy in electrical transportation, which it is incredibly important to the functioning of electric vehicles and other forms of electric transportation. There is 4 roles of electricity in transportation that I will explain. The first one is electrical transportation relies on electric motors to convert electrical energy stored in batteries into mechanical energy for propulsion. The second one, the role of electricity is energy storage, which electricity in transportation is stored in batteries or other energy storage systems, which it helps to reduce dependency of fossil fuels. The third one is clean energy sources. The use of electricity allows for the integration of the renewable energy sources such as solar, wind power into the transportation sector. Last one is environmental impact. While using electricity in transportation, we could avoid using traditional fossil fuels like gasolines and diesels, so it can prevent greenhouse gas emissions or mitigating air pollution. So now we are going to move on what is the role of magnetism in electrical transportation. There's 2 that I choose for this role, which first, it says that it can recharge a car while driving. How does it work? We use magnetism to transmit electricity wirelessly to recharge the electric cars, where wireless charges transmit electricity by creating a magnetic field that oscillates at a frequency that creates a resonating vibration in magnetic coils on the receiving device. And the second one is magnetic levitation, called as maglev. Magnetic levitation is a technology that uses a magnetic force to suspend, guide, and propel objects, often in the context of transportation systems, which this magnetic levitation is highly efficient and environmentally friendly transportation method, where it enabling near frictionless movement of vehicles on tracks. The first material that is used is superconducting materials. These materials can conduct electricity with zero resistance when cooled to low temperatures. When the superconducting wire is immersed in liquid helium, it enters the superconducting state and produces a powerful magnetic field for levitation and propulsion without energy loss due to electrical resistance. The second material that is used is cryogenic cooling systems. This system utilizes the liquid helium or nitrogen to effectively maintain the superconductors at lower temperature, which it ensures that the superconductors remain in their desired state and are able to effortlessly conduct electric current without any resistance. The third material used in maglev train is electromagnetic suspension, which is EMS. Electromagnetic suspension levitation of the train is accomplished based on the magnetic attraction force between a guideway and also the electromagnets. It helps to levitate the train. The fourth material used is electromagnetic coil. The function of electromagnetic coil is for propulsion. How does it work? As the train is in motion, the electromagnetic coils on board interact with the magnetic field of the guideway, which resulting in the induction of an electric current. This induced current generates a secondary magnetic field, which effectively propelling the train forward. And then the fifth material that is used in magnetic levitation train is they use a lightweight structural materials, such as aluminum alloys, carbon fiber reinforced composites, and also the titanium alloys. And the sixth material that is used is linear induction motor, which operates on alternating current AC and generates linear motion. It composed of a primary component called the stator and also a secondary component known as the rotor.
how does it work? It utilizes in medium and low speed maglev trains due to their numerous advantages. So now we are going to touch about what is the benefits and also the challenges of magnetic levitation train. First, magnetic levitation train does not need wheels because they float on a magnetically supported trail racks. Compared to the bullet train or traditional trains, it runs on wheels. The second benefit is it has a lower environmental impact because magnetic levitation rail is environmentally friendly due to their lower energy consumption, reduced emission, and quieter operation compared to the traditional train. The third benefit is magnetic levitation train is energy efficiency, which the absence of wheel and track friction means less energy is lost as heat during operation. What is the challenges of using a magnetic levitation system in a train? First, it has high initial cost, which magnetic levitation train has expensive tracks and also guideway. The second challenge is it has a limited infrastructure, which magnetic levitation train system require a dedicated infrastructure, including purpose-built guideways.
We're going to talk about the future in development and innovations of electrical transportation. The potential economic and environmental benefits of electrified transportation make it a strong candidate for stimulus money both now and in the future. Hence, year by year, our mankind continuously innovating something new with a great development for all electrical transportations. Utilities and organizations transportations are pushing forward with innovations like solid-state batteries that allow for faster charging and smart systems that link vehicles and grids, which can enhance grid reliability and power management, even as the current charging infrastructure grows. These are the innovations and development of electrical transportations that have been found as now. Firstly, solar-powered trains. British Train Power is being directly connected to a solar panels by a team led by Imperial College London. The idea of directly connecting solar panels to the lines that supply trains with electricity is creative and entirely original. By doing this, the electricity system will circumvented, enabling the panels to deliver power exactly when it is most required. Secondly, magnetic levitation trains, SC maglev. Even it's thought as the ground transportation of the future, maglev trains actually don't touch the ground. The train also doesn't have any wheels, and the only resistance that it has is air resistance because it is meant to float 10 millimeters above the track, which allows it to travel at a very high speed. This train accelerates and decelerates by magnetic force produced between the onboard superconducting magnets and ground coil. It is also opposite with traditional railway system, which there is addition between the wheel and the rail. Last but not least, electric aircraft. Although electric aircraft technology is still in its infancy level, but investments are being made on a yearly basis. However, there is a lot of disagreement over the viability of electric aircraft. Some people believe that there is no way to solve this issue, but others believe that things are getting better every year and that by 2026, electric aircraft will be commonplace. Since the last century, society has evolved into one that is better and more sophisticated, and the transportation is no exception. In many respects, technological advancement promise to raise the bar for transportation. But we have never looked back since the invention of the motor vehicles when it comes to coming up with fresh, inventive designs and building cars that are more efficient with more physics concepts on the innovations itself. For the first example is magnetic levitation trains. The concept is to utilize the principles of electromagnetism by levitating and propelling a train along specially designed tracks. Another example is electric trains. Across the world, people rather than cargo are primarily transported by electric trains. Their electric motors are supplied with power via a receiver that stays connected to an electricity wire running parallel to the train. To conclude the context of this video, automobiles have been utilizing the concepts of electricity and magnetisms.
Hold me close till I get up. Time is barely on our side.